Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 40 from the Smith Organic Chemistry textbook. And in this problem, we're asked to draw a stepwise mechanism for this polymerization reaction to go from isoprene to gutta-percha, which is a natural product. And we're told which initiator to use. And so that's where we'll begin. So this is clearly a radical polymerization, and the clue there is that we have this initiator. It's a peroxide, and so we can go ahead and draw that. So CH3, 3C, OO. So remember, these oxygens don't really care for one another. They do not like being bound together. So they'll go ahead and split. And that bond splits to give us our actual initiator species. So we end up with two of these radical species. So I'm just going to draw one. We only need the one, really. So the oxygen here has a radical electron on it, so an unpaired electron. And so that's going to be our species that actually kicks this radical polymerization off. And then here is our isoprene that we're told to use. And so remember the way that this is going to work. We've seen it before in this chapter. So the radical electron is going to come together with one of the electrons from the double bond to form a new bond. The other electron from the double bond will revert to the carbon that's not taking place, or that's not taking part in the new bond. And so that gets us to this point. And our unpaired electron is now residing on that carbon. And so that's the end of the initiation step. So remember, these radical reactions have three steps: initiation, propagation, and termination. So the propagation step is what's going to happen over and over again to make this polymer chain grow. And so to begin, we have our product from the previous part, from the initiation step, and I'm just going to draw it a little bit differently. So here's our product, here's our radical, and so this is going to rearrange, and we can visualize that like this. So the radical and one of the double bond electrons will come together to make a new double bond, and the other double bond electron will revert to the carbon that's not taking part of the new double bond. Right. So it's an allylic radical, so it is able to move around like that. Oops. And I do apologize. It looks as though I dropped a carbon. So let me go back and fix that. So there should be a carbon here and then the oxygen. Okay. So I won't make that mistake this time. Right, so we now have a double bond there and our radical there on the terminal carbon. And so what's going to happen next is that newly formed terminal radical is going to react with another isoprene unit. So here is the next isoprene. You know what? I don't like the way that looks. So here's the next isoprene. And what's going to happen here is exactly the same as what happened in the initiation step. So the radical and one of the double bond electrons come together. The other double bond electron reverts to the non-participating carbon. And I'm just going to change the orientation around a little bit here just to make it a little easier to see. So now we have a radical here. And so, again, this radical can rearrange and then attack yet another isoprene, and on and on and on. Remember, propagation steps are repeated over and over again. So I'll just write repeat over and over. So, so propagation steps are repeated over and over again to grow the polymer chain. And then lastly, to stop this chain reaction, what's going to happen is basically a radical, rather than reacting with another isoprene unit, a radical is going to encounter another radical, and they're going to come together and form a new bond, and there won't be a radical left over. So what we could envision that looking like is something like this. So we have our chain that we've been growing. So here's that chain. It's going to have a radical at the end of it on this terminal carbon again. And so rather than encountering a fresh isoprene with which to react, it could encounter another radical. And so here's another radical on a terminal carbon. And so these will come together and form a new bond. And when they do so, there will not be a radical left over. So since there won't be a radical left over, this reaction is terminated. There's no more reactive species to continue the reaction. So here is what this product would look like. And you know, if we wanted to, I guess it would be a little cleaner looking to draw it like this. So rather than that weird straight bond that I put in there, we could draw the final product like this. So yeah, so that looks a little nicer. And so that's our polymer that we've made. We've terminated the chain reaction. And so, again, the key to this problem is just remembering your radical chemistry. So there's an initiation step, a propagation step, and a termination step. And yeah, that's the answer to chapter 31, problem number 40.